All right, in number 12 we have the definite integral of an absolute value function. We see the absolute value of x right here. So in this case, I think I do want to just graph this and then find the area under the curve because that's what we know the definite integral represents. And so let's go ahead and just graph the absolute value of x. And when we think about this, remember what we can do is just graph the function x, which will look like this. And anywhere the function goes below the x-axis, okay, where it's negative, it basically flips over the x-axis and becomes positive. And so our function looks something like this right here. All right, so here is your absolute value of x function. Now we want to find this from -1 to 3, so I'll just call this -1 here, and we'll just say 3 is over here. And what we're trying to do is find the area under the curve from here to here. And what this does is it actually creates two different triangles for us, and we can find these triangles fairly easily. So if we look at the triangle on the left, we know the base is 1 and the height is going to be at -1. And so the absolute value of -1 gives me a +1. If I'm over here at 3, I know the base is going to be 3, and if I find the absolute value of 3, the height will also be 3. So we really just need to find the area of these two triangles and add them together. So the first one will be 1/2 base times height, so 1/2 1 times 1. And that is the very first triangle there. And then we'll add the second triangle to it, which is 1/2 base times height again, so times 3 times 3. And that's our second triangle. And so the first triangle looks like it's just going to equal 1/2, and the second one looks like it's going to be 9/2. And so all in all, we get 10/2 or 5. And so this definite integral is going to equal 5. So don't forget that the definite integral does equal the area under these curves, and so if it's something like this, it might be helpful to solve this way.